All right, guys, just confirm, can you see my slide? Can you see my slide, guys? Confirm, guys, can you see my slide on the screen?
Yes.
All right, thank you. I'm hardly actually hearing you, so I'm not sure if you can hear me loud and clear on your side. All right, guys, today we're going to actually focus on the topic for probabilities. I think we once did this topic, but it was actually unfortunate to the previous lecture. We were actually holding the lecture on my absence. It took you back to the last chapter for a regression. I was thought maybe it's going to cover the fourth chapter, which is for probability. But anyway, I'm just going to take you through the topic for probability as well as the next one, which is the binomial distribution, the normal distribution topic. But if we might not be able to complete all the topics on this workshop, I already actually talked to the department to organize another workshop for you guys before the exams, so that maybe we are going to have another workshop where we're actually going to have all touch-ups on all the remaining areas that need to be covered before exams. I think there's someone who is saying something. I can just hear the voice there. Masito, I'm not sure if you are saying something. Can you kindly switch off your mic if you don't have any issue? Yes, thanks for that. Thanks, so that at least you minimize noise. All right, so I'm just going to take you through. Before I start this topic, is there any question or anyone who have something to say? Okay, I assume that everyone is sorted. So I hope everyone submitted the assignments, because I haven't started marking your assignments, but very soon I will be actually starting marking your assignments as well. So expecting your assignment results maybe around mid-June, somewhere there, but first week of June, actually I think I'll be almost done marking your assignments. So if anyone has anything to say, you just contact me anytime, either through my WhatsApp or through my email. Then if you have got any problem regarding maybe exam preparation or anything that you might actually need assistance, then you just contact me. Okay, so the topic for today is introduction. We're going to start with the introduction to probability. So in this topic, we are going to focus in what we call simple probability and conditional probability, and then we're going to have a look on what we call binomial distribution probability, and then after this we're going also to have a look on what we call the Poisson distribution, and we are going to also have to look on what we call the combination and permutations. Okay, so in basically a simple probability, we once actually talk about this. A probability in general is just a game of chance. When you actually want to find out what are the chances of an event to occur, or what are the chances of something to happen, that's what we call the probability. So the probability of an event is the number of favorable outcome, then divided by the total number of possible outcome. So if you, okay, I heard someone is talking again. I'm not sure. Can you kindly switch off your mic? So is there anyone who have got a question before I proceed? Okay. Say probability in general is simply the game of chance. The probability is actually the calculation of how possible an outcome can occur or an event can occur. So when you're calculating the probability, either you might actually calculating the probability of maybe two teams. I was actually want to give you this example. Say if I say there are two teams that are playing today, what is the probability that one of the team is going to win? So if there are two teams, A and B, if I say what is the probability that team A is going to win? So there are only one way one team is going to win. So either that team is going to be win, or they're going to lose, or they're going to draw. So the possible outcome is going to be 3. But the only one way, there's only one option when the team going to be win. So when I say what is the probability that the team A is going to be win, it's simply going to be one option divided by the total possible outcomes, which is 3. It's either win, draw, or lose. So it's going to be 1 over what? 1 over 3. So the probability that team A is going to be win is going to be 1 over 3. So always when calculating probability, probability is simply going to be the total number of favorable outcomes divided by the total number of all outcomes that can occur. So for example, that I was giving here, I was giving the example that is saying, what is the probability that if you toss two dice, one after the other, what is the probability that the total of those two dice are going to add up into 5? So what is happening now, you need to find out how many possible outcomes, how many favorable outcomes that give you 5 when you toss two dice. So the die, you might actually toss the first die, and the first die land and give you the side of what? Of 1. And then the second die give you the side of what? The side of 4. So this actually add up to 5. So this is another option that might actually happen. Okay, so the other way that might also happen, either the first die can land with 4, and then the second die can land with 1. So it gives you also the total of what? Of 5. And the other option that might happen also, the first die can actually land with 2, and the second die can land with 3. And if you add them, they give you 5. Or the first die can land with 3, and then the second die can land with 2. So this is another occurrence that might also happen. So these are only 4 options that might actually, the favorable outcome that might occur, and that gives you also 5 if you add them. So if you actually if you are answering the question that is saying, what is the probability that the sum of two dice will be equal to 5? Which means you need to find all the possible outcomes and count them. How many of them? If you count, there are 4 of them. Then all divided by the total number of what? Total number of all the possible outcomes that might occur. So the possible outcome, if you list them, all of them, they are going to be 36, which means it's simply going to be 6 times 6. 6 times 6 is simply one die might land with 1, and the other one might land with 1. One die might land with, if you list them, different occurrences that might happen, they're going to be 36 in total. But the favorable outcomes, which we are asking here, which are asked by the question and say, which gives you a total of 5, there are only 4. So the probability of those two dice to give you 5 is simply going to be the favorable outcome over total number of outcomes, which is 4 over 36, and give you 1 over 9. So that's how you calculate probability. So I was giving you also the example of the team. That's actually the other one that you can use in probability when you actually want to find what is the chance that team A, when team A and team B are playing, what is the probability that team A is going to win? Which means there's only one way team A can win. But other possible outcomes, it might be draw, it might be losing. So if you check all possible outcomes, there are 3 of them, which is draw, lose, or win. But if I say what is the probability of that team A winning, which means it's going to be 1 divided by the total number of possible outcome, which is 3. So the probability of team A winning is going to be 1 over what? Over 3. So that's how actually you also calculate probability. You just have to know on simple probability, how do you deal with the calculation? You have to identify the favorable outcomes, then you divide by the total number of all the outcomes in question. Okay, so I've got another example here that is also saying the sample survey had 500 respondents, of whom 200 were men and 300 were women, which means it's a survey that you are taking, but you are taking the survey to 500 respondents that are actually participating in a survey. But this 500 composed of 200 men and 300 what? Women. Then the question comes now and say, what is the probability of picking a man? If you pick one person at random out of this group, the question is saying, what is the probability of that the person that you pick is a man? Remember, when you are doing this, it's more like you are doing it without randomly, without knowing. Let's say you are blindfold your eyes, then you just randomly pick someone. So I'll be actually asking, the question might actually ask and say, what is the probability that what you pick is a man? So you need to find, which means out of all the total number of men that we have, which is what, 200, any man have a chance of being picked. So if I asked about the probability of picking a man, which means you simply say the favorable outcome of these total men that I have, which means any man can be actually have a chance of what, of being picked, which means it's going to be the total number of men that are there divided by the total number of people where you are picking, which means the total number of all the objects or all the people that where you are picking, there are 500. So it's simply going to be the total number of men divided by the total number of all the people where you are picking a man. Okay, so that is the probability of picking a man, because any man out of these 200 have got a chance of being picked when you are picking a person out of them. So that's how you actually calculate the probability. So the answer is simply going to be 0.4. The same applies when I come to the second one. Also, it's as saying, what is the probability of picking a woman? Picking a woman, which means how many women do I have in my survey? I've got 300 women. So when I pick a person, any woman out of these 300 have got a chance of picking. And it's correct when I pick any of them. It's correct because I need the probability of just picking a woman. So how do I calculate that? I simply say favorable outcome, number of favorable outcome, which is 300, divided by the total number of all the people in my survey, which is 300, which is 500. So I was simply going to get what? 0.6 is my probability of getting what? Picking a woman as well. So I hope it's actually clear on your side there. So expected outcome is called probability that a particular outcome is okay. Yeah, don't worry about this one. We're going to talk about it later now. On the example 3, that's where I actually want to talk about the expected outcome. Okay, I have got another example. Let's say you are talking about the coin. Everyone knows about the coin. The coin has got what, two sides, which is a header and a tail. So when you toss a coin again, you either actually get a header, it might actually land with the side which is the header or the tail side. So if you toss that coin and say throw it up, then I'll ask you, what is the probability that it's going to land with a head? You're going to get a head. So you need to actually find, so how many heads do you have on a coin? There's only one head, but how many possible outcome that might happen when you toss a coin, which means that coin, it might be land on the head side or it might land on the tail side, which means there are two total possible outcome. But how many heads are there? It's only one. So the probability that you are going to get a head when you toss that coin is only going to be number of heads that are there, which is 1, divided by the total number of what sides or possible outcome that might happen when you toss that coin, which is 2. So that's how you get what? This half, okay, which is 0.5. That's actually the probability of getting a head when you toss a coin, okay? Okay, then if I ask you and say, okay, if a coin is tossed, maybe you toss that coin repeatedly for 500 times, then I'll ask you, how many heads would you expect to get? Because now you probably know that if you toss a coin only once, the probability of you getting a head is half, which is 1.5. But if I say, okay, you toss a coin 500 times, then I'll ask you, how many heads do you expect to get? Obviously, the heads is going to be, normal circumstances. You expect to get the half of what? Half of your tossing as heads and half of the tossing as what? As tail. Which means if you toss 500 times, how do you get the number of heads that we expect? You simply say the probability of head multiplied by the number of tossing. How many times did you toss a coin? Which means you simply multiply it with the probability of getting a head. Then you get the number of what? The number of heads you expect to get when you toss for that amount of what? For that amount, which is actually 500 times. When you toss it after 500 times, you expect you to get 500 times what? Times the probability of getting a head, which is 0.5, and it's going to be 250 heads. So if I ask you again and say, if you toss a coin, now, what is the probability that maybe you toss it for 10 times? It's the same coin, But now you are not tossing it for 500 times. You are tossing it for 10 times. How many heads are you expecting to get? I'm just posing this question to you. Is there anyone who have got an idea? Just confirmation if we're still together. Are we still together, guys? I just want to try to not to monopolize our lecture, so that at least I'll get confirmation from you whether we're still on the same page. Or just confirm, are you still with me? Can you hear me?
Yes.
All right. All right. All right. Since there's no one who can give me an answer, okay, let me just proceed. Okay. If you toss a coin, which means you toss it for 10 times, you expect also to get the probability of heads, which is 0.5 times 10 times, then you get what? You get 5 heads. That's what you actually expect. So you simply say the probability of that head times what? Times the number of tossing. How many times are you tossing your head? Then you can get the number of what? The number of heads you're expecting. So if you toss it for 10 times, you'll be expecting to get what? 5 heads and also 5 tails. Since the probability of getting a head is what? It's 1/5, which is half. Okay? So I've got also a question that is saying, if you roll a die, what is the probability of getting a 4? So these are actually simple, okay? A die, if you roll that die or it was that die, what is the probability that you are going to get a 4? Is there anyone with an idea? All right, since there's no one, let me just proceed. Okay, if you toss a die, I told you that it has got 4 sides and it has got 6 sides. So that 6 sides, actually each side is numbered from 1 up to what? Up to 6. Those sides are numbered. You've got numbers 1, 2, up to 6. So if you toss a die, the die can land with any side, which is either you can get a 1, you can get a 2, you can get a 3, you can get up, you get what? A 6. So those sides, if you toss it only once, any side, you can get any side of that die. But if the question now comes and say, what is the probability that you get a 4, which means what is the probability that the die is going to actually land with the result of a 4 on the side that you've got a 4, which means how many sides that you've got a 4 on a die is only 1, but how many total sides of a die that might possibly land when you toss a die, because it might actually land with any side. So we have got 6 sides of your die. So the probability of getting a 4 out of those sides is simply going to be 1 divided by what? By the total number of sides of a die, which is 6. So the probability of getting a 4 is simply going to be 1 over what? 1/6. So that's how you simply answer this question. Okay? The question that I have, which is the next one, is saying, if you roll it 200, if you roll it 200 times, how many 4s would you expect? The same applies here. If you roll it 200 times, you expect it to get also. The question is actually asking you, say, how many 4s would you expect to get? Which means the number of times you actually expect to get your 4 is simply going to be the probability of getting a 4, which is 1 over what? Which is 1/6 times the probability of times the number of times in which you toss your die, which means you simply multiply by 200 and then get what? Get the number of times in which you expect to get what? You expect to get then you expect to get those 4s. Okay, so it's simply going to be 200 times 1 over what? Times 1/6, which means 1/6. Then you expect to get 33. You expect to get 33 because it's actually you have a fraction with 33,3. So you're expecting to get 33. You expect to get 33 4s. When you toss a die 200 times, you expect to get what? So it's simply, you have to take the probability of getting a 4 on a die, which is 1/6, times the number of the number of times in which you toss or you roll a die, then you multiply it, then you get what? 33. So this 33 is the number of what? Number of fours that you are expecting to get, okay? So that's how you calculate it. So I hope I'm clear on that, okay? All right. So in probability, we have also what we call the mutual exclusive and non-mutual exclusive probability, okay? Mutual exclusive is only, we say that the mutual exclusive, it only happens when the two events, when the two events are not possible for both of them to occur at the same time. Let's say I'm saying now, what is the probability of what? Of getting, if you toss a die now, or a die, what is the probability that you are getting a 4 and a 1? What is the probability of getting a 4 or a 1? So if you check, if I say, what is the probability of getting a 4 or a 1 if you toss a die? It's not possible for you to get both. The only way you can only get one of either. You can get a 4 or you can get what? You can get maybe a 2. You can't get both at the same time. So whenever we're actually calculating this probability and say, if a question comes and say, what is the probability of getting this or this? If it's not possible for those two events to happen at the same time, then we call it mutually exclusive, because it's not possible for you to toss a die and get both two numbers at the same time on a die. It's not possible. So once you are actually analyzing a statistical event that is not possible for both of the events to occur at the same time, then we can call it mutually exclusive. So you need to know how do you actually apply the statistical formula for calculation of that. So it's very pretty simple. When you're calculating that probability of a mutually exclusive, you simply have to find the probability of one, and then you add with the probability of the next one, then the other. That's how you calculate the probability of a mutually exclusive event, where the situation is not possible for both of the events to happen at the same time, okay? So if I ask you and say, what is the probability that today is going to rain, or is going to be a Sunday? So it's not possible sometimes to happen at the same time, to be raining at the same time there's a Sunday. At the same time, it's not possible. So which means if I say probability of being a raining and the probability of what? Or raining or being sun, which means you need to find the probability of being raining, and then you add with the probability of being what? Today is going to be a sun, then you can add them together. That's how we find, which means it's mutually exclusive, because it's not possible for both of them, those two events, to happen at the same time. So once you are dealing with such kind of probability, we call them mutually exclusive events, because they are occurring in different they happen actually differently. They don't occur at the same time, okay? So I've got an example like the one that I was giving you now. What is the probability of rolling a die and getting either a 2 or a what, or a 3? Well, automatically when you are rolling a die, you can get a 2 or a 3. So when you are finding this probability, you need to find the probability of one, and then you find also the probability of the other, then you add them. That's what you call the probability of what? The probability of a 2 or a 3. It's mutually exclusive, because it's not possible for you to get a 2 and a 3 at the same time when you toss what? When you toss a die, but they happen independently, okay? So that's what we call mutually exclusive. I hope I'm clear on that, okay? So we have also what we call a non-mutually exclusive events. So the non-mutually exclusive events, when it is possible now for both of the events to occur at the same time. So when you have got a situation where it is possible for both of the events to happen when in your statistical study, or where you're actually finding the game of outcomes, or the probability. If you check those events and you find out it is possible for both to happen at the same time, then for two events to happen at the same time, then we call it a non-mutually exclusive events, those type of events. So an example that I have now on my screen with the calculation is for a die. So for example, the question is saying, what is the probability that a card selected from a deck will be either an A or a spade? I'm not sure if everyone is familiar, but this actually is very important for you, especially in statistical questions. It's very important for you to know about all these things like coins, dice, as well as the cards. The cards, I think most of you know how you once used to play those cards. So those cards, you must know actually how many cards. So when we're talking about the deck of cards, we're talking about that pack of cards that you are used to play. So you need to find out on how many hearts do we have in those cards, how many how many spades do we have? How many syrups do we have? How many syrups or clubs do we have? Then also, how many diamonds do we have? So those actually are important when it comes to statistical questions, because those are the questions that they might actually ask you using those general field of the cards and the coins, as well as the dice. So you need to be actually pretty familiar with the components, or how many spades we have in our deck of cards. So generally we have got 13. We have got total 54 cards, because we don't actually count the jokers, those two jokers that we have. So you have to count only the hearts. So we've got 52 cards in total in a deck of cards. And out of these 52, you divide them by 4, which means you have got 13 hearts, 13 diamonds, 13 spades, and 13 clubs. So each and every type category, we have got 13 of them. So on those 13, for each, we have got also numbers, numbered from 1 up to 10. And then we have got what jack, we have got what king, then we have got what queen on each and every as part of those 13. So it's actually pretty much important for you to know about the structure of all the cards that are in the deck of cards, so that when you encounter any statistical questions that are asking you about cards, you'll be able to approach them. Okay. So, for example, the question is simply saying, what is the probability that a card selected from a deck will be either an A or a spade? So, this one, it is possible for you in a deck of cards, we have got an A that is also a spade, because each and every A, we've got 4 A's that we have. So, we have got an A of heart, we have got an A of spade, we have got A of diamond, we have got A of clubs. So, if the question is saying, what is the probability that it's a card selected will be either an A or a spade? So it is possible for you, when you're picking a card, to pick an A that is also an A for spade. So once you find a situation where it is possible for you or for an event to occur at the same time, for these two events to occur at the same time when you are actually picking a card, then you can actually call it a non-mutually exclusive. So how do you actually calculate the probability? You simply have to find the probability of picking an A independently, and find the probability of picking a spade independently. Then you find also the probability of both events happening at the same time, and then you subtract it from what? From the total. So this is actually the general formula that you use in a non-mutually exclusive event, where you're saying the probability of A or the probability of 2 is equal to the probability of A. You find the probability of A independently, then you find also probability of B independently. Then now you need to find the probability of B and A happening at the same time. Then you subtract it from what? From this total of addition of 2 probability. So that's how you calculate what? A non-mutually exclusive probability. Okay. So for example, in my solution here, I'll simply list the probability of A. The probability of an A is simply going to be, how many A's do I have in a deck of cards? In the deck of cards, I have got 4 A's. So the probability of picking an A is simply going to be 4 over total number of cards that I have, which is 52. So that's the probability of picking an A. So what is the probability of picking a spade? A spade is simply, how many spades do I have in my deck of cards? I have got 13 spades. So I simply going to have 13 over total number of cards that I have in my deck, which is 52. So that is the probability of picking what? A spade. Okay. So what about the probability of picking both a card that is both an A and what? And a spade? So how many cards do I have which is an A as well as a spade? It's only one. So an A, I've got only one A, which is a spade. So the probability of picking an A, which is a spade, that's why I'm saying and. And it simply means you have to satisfy both conditions, both sides. So it's simply going to be 1A over what? Over total number of cards that I have, which is 52. So when I pick a card, if I say what the probability that card is an A and also is a spade, well, it's simply going to be 1 over 52. So when I'm calculating now in overall, which is the probability of an A or what? Or an A or what? Or a spade, it's simply going to be the probability of an A, which I calculated here, plus the probability of a spade, plus the probability of a spade here, plus the probability of a spade, which I calculated also up here. If you check 13 over what? Over this one, which I calculated, then I'll add them, then I'll subtract the probability of an A and what? And the spade, which is 1 over what? 1 over 52. If you check here, This is my calculation that I put here, and the answer is simply going to be 4/13. So that's how we calculate the probability in a non-mutually exclusive event. So non-mutually exclusive events, it's only in a situation where it is possible for both of the events. So when you are dealing with those situations where it is possible for both of the events to occur at the same time, so you have to know that they are non-mutually exclusive and how we are going to apply the calculation on them. You have to calculate you find the probability of each individually, then you find also the probability of both combined, and then you subtract from the addition of their independent probabilities. So that's how you calculate that. Okay. So after that, we have also what we call the independent events. Independent events in probability is a word, independent, it's just a general term that I think everyone, when I'm talking about you are independent, event is independent, which means it doesn't depend on any other event. So when I'm talking about independent events, which means those events that are actually independent from each other. So when we have got maybe an event A and B they are said to be independent if the occurrence of one doesn't have any effect on the other occurrence. So when those two events are happening and without have any influence on each other, we call them independent events. Okay. So when we're finding the probability of independent events, you need also to know how are you going to deal, and you have to identify whether the probability that you are calculating on a statistical study or whatever situation that you are actually calculating the probability, you are dealing with what called the independent events or they are dependent events. Okay. So for example, that I have on the screen, say the probability of a machine breaking down is 1/10, and the probability of a stoppage of raw material is 1/8. What is the probability of machine breakdown and the stoppage of supply? So if you check the probability of machine breakdown, it doesn't have anything to do with the probability of the probability of stoppage of raw material. They don't actually link on each other. There's no relation between machine breakdown and the supply of what and the stoppage of raw material. There's no relationship at all. So the probability of stoppage, if I answer the question that is then say, what is the probability of machine breakdown and stoppage of supply? So which means I actually need to find the probability of these two combined, which is the probability of machine breakdown and the probability of stoppage of supply. So what you have to do in an independent events, you simply have to multiply the probability, which means you have to multiply this probability of what of a machine breakdown times the probability of what a stoppage of supply. That's the answer of both probabilities combined in an independent. That's how you calculate the probability in what in an independent event. You simply multiply them, then you get what the total if you are combining them. Okay. So to answer this question that is here, you simply have to what to multiply your probability. So if you check here the solution, the probability of breakdown and the probability of stoppage is simply going to be 1/10 times what times 1/8, which is this answer that I'm quoting here in a what in an independent. So another example of independent events is if I say if you toss a coin now, what is the probability that what is the probability of getting a 2 and a 1? Maybe you're tossing 2 dice, and what is the probability of getting a 2 and a 1? So if the probability of tossing 2 times, maybe you're tossing for the first time getting a 2. Getting a 2 doesn't have any influence on the next tossing that you're going to have. So the next tossing, it doesn't determine that on the next tossing you're going to get this because now the first tossing, the outcome of the first tossing was 2. It doesn't have any influence. So if I ask you, so what is the probability that if you toss a die 2 times, you are going to get a 2, and then we are going to get a 2, and then the second one get a 3. So in that situation, you're simply going to say the probability of getting a 2 times the probability of getting what? Of getting a 3, which is 1/6 times 1/6, because they don't have any influence on each other. Those two events when they're occurring as well. Okay, so they are independent. So when you're calculating this probability in a situation where you've got independent events, you simply have to what? You simply have to multiply the probabilities, and then you get the answer. Okay, so we have also what we call the non-independent events. Okay. Non-independent, it simply means they are depending on each other, which means the two events when they're occurring, the occurrence of one event is going to have an influence, either a positive influence or a negative influence on the next event that is going to occur. So once you have got such situation in any statistical study, you know that you are dealing with dependent what called the dependent or a non-independent situation, non-independent event that you are dealing with, okay? So when you're calculating those probabilities where the events are depending on each other, you need also to cater for the effect that are actually caused by one with the occurrence of the first event before the second one occur, okay? So in the situation that I have here, I have got an example again for non-independent. Say, if someone draws a card at random from a deck, and then without replacing the first card, draws a second card again, okay? And so if you check on this question, they are simply actually asking you about the first picking of a card. You are picking the first card from the deck of cards, and when you pick, the first picking is going to cause a problem. It's going to cause a subtraction of cards in the total cards that we have. So when the second person is picking, or when you are picking for the second time, you are no longer picking from the number of cards that were there previously. You are picking from the lesser number of cards, which means in this situation we can say the second picking is depending on the first picking. So these two actually events, they actually have a dependence on each other. They have got an effect or influence on each other. So in this situation, we call them non-independent events. Okay. So like the question that say, what is the probability that both the cards will be A? Maybe all the cards will be A's, isn't it? So if you are picking the first A, let's say you are picking the first A from the deck of cards. How many A's do we have? We have got 4. So if you pick one A from out of 52, obviously you're going to get the probability of picking that A out of 52 is going to be 4 over what? 4 over 52, because you are picking from 52 cards. But how many A that you have? You've got 4 A's in that 52. So any A out of those 4, you've got a chance of being picked. That's why we are saying 4 over what? Over 52. So when the second picking are happening, the second picking say, okay, now pick for the second time. You are no longer picking from 52 because the one card is already subtracted. When you're picking for the second time, you're picking from 53. So if you first one, you pick an A, and I say pick the other card again, and I will ask, what is the probability that you are going to pick an A? Of course, now it's going to be how many A's are you left with in the deck of cards, because the first card that you picked, it was an A. So which means now you're no longer having 4 A's, you've got 3 A's left. Okay, so the second, which means you are now picking in 3 A's out of how many cards left? 53. They are no longer 50. It's 51. They are no longer 51. They are no longer 50. 52, because it's subtracted. So they are left with as 51. So it's going to be 3 over what? 3 over 51. Okay. So if I say combine them together because they are dependent, you simply say the probability of an A and the probability of a B is simply going to be the probability of A, which is the first picking, times the probability of the second picking that we're having influenced by the first one, the first occurrence of an event. Then you multiply them together and get this one is the probability of an end. So always actually cater, be in mind of what we're asking, whether there's an or and there was an end. Because an end means both things are actually asking combined together, happening at the same time when you're asking about an end. So they're saying the probability of this one and this one combined together. So end, it's normally we're in the situation where we use the end, which means you need to cater for multiplication. And simply means a multiplication. But in a situation where we have got an or, it's where you have to apply addition of maybe different probability together. Then you'll be adding them together. Then if you are saying an or, that's the other thing that you also have to bear in mind so that you won't be lost. You might actually quickly remember what kind of calculation to apply whenever you are dealing with certain probability. So whenever you're asking an end, which means it's more like example, you're sending your kid now and say, go to the shop and buy me a drink and some biscuits. So if your kid brought some biscuits and without a drink, which means your kid failed, because you actually send your kid to buy a drink and a biscuit. So you expect both things to be brought by a kid. So if your kid bought only one, which means actually failed. So when in a situation where we're using end, you expect both things to be to happen. So that's why you multiply them together, then find what this one. But in an or, which means you are saying this one or this one, that's why you apply addition in a situations where we have got an or. Say this one or this one, okay? So you have also to be in mind of that, okay? So beside a non-independent event, we have also what we call the conditional probability, okay? Conditional probability is more like similar to dependent, to the one that is non-independent, which is dependent, where the events are depending on each other, okay? So in the conditional, it's more like you are given a condition, you say, you know what is a condition. When you're given a condition, you are saying maybe when this, what is actually, you actually asking me maybe the probability to say, what is the probability of getting this? When is this? Which means there is a condition that will be actually given for another event to be happening in such a situation where there is a certain condition which will be given, okay? So conditional probability is an event that will actually occurring given that the other event is already happened or has already occurred. So you might actually give a condition, say, what is the probability that maybe, let me give you an example now and say, maybe in your basket, in your dining room where you're sitting, you've got some fruits on your table. Maybe in that basket of fruits, you've got maybe 3 oranges, and you've got 3 oranges there, and 3 oranges. Let's say you've got 3 oranges, and you've got also let's say you've got 5 apples. You've got 5 apples in a basket there. They're mixed in a basket. All of them, they're mixed. They're mixed up. 5 apples and the 3 oranges that we have, okay? So if I ask you and say, what is the probability that if we pick a fruit, I'll blindfold it to you, then I say, pick a fruit in that basket on a table. Then I'll say, what is the probability that you are going to pick an orange? So you should know how do you find the probability of picking an orange? What are the chances of picking an orange when you pick a fruit from that basket that you've got 5 apples and 3 oranges? So it's simply going to be the number of oranges that you have, which is 3 over what? Over the total number of fruits that are in a basket, which is 5 oranges, 5 apples plus what? Plus 3, which is over 8, which means 3 over 8. Okay? But if I'm saying now giving a condition and saying, a condition now, it's more like you are giving a condition of one event has already happened and you ask it about the occurrence of the second event. So I can say, what is the probability that the second fruit that you are going to pick is going to be an apple? What is the probability that the second fruit that you are going to pick is going to be an apple, given that the first fruit is an orange? So that is actually a condition, because you are only told that the first fruit that you picked is an orange, and you're asked about the probability of picking apple as a second fruit. So that's actually it's a condition now, because the question is already telling you that what is the probability of picking an apple as a second fruit, given that the first fruit that you picked is an orange. So you are given a condition. So that's actually situation what we call the conditional. So in that situation, you simply have to know that the first picking, it was the one that you picked from, an orange picked from where? From 8 fruits. But now, remember, you're no longer picking from 8 fruits, which means the second condition you've got influenced by the first picking of an orange. But the second picking, you are picking from 5 apples. But out of how many in the basket? Because they were already the first fruit that were picked, which means you are no longer having 8 fruits in a bucket, but you are left with what? You are left with only 7 fruits. So which means you need to cater for that. It's always the second picking it will influence, because you are given the condition of the first occurrence, and now you are calculating. You want to find out what is actually the probability, given that this condition, what's the probability of the second actually a probability to happen, which is you're picking an apple. So you're going to simplify the probability of what? Of 5 over divided by 7. So you need to find out what are the probability of the first occurrence, which is the conditional one, which is of apple. Apple is 3 over 8. Then when you're picking the second one, the probability of picking an apple now is going to be 5 over what? Over 7. So when you're combining those probabilities now, it's going to be 3 over 8 times what? Times 5 over 7. Then you find the probability given that condition. So that's how you calculate it. When you're talking about conditional probability, that's how actually meant when you. That's what it means when you're talking about the condition, which means you'll be asking about the probability given a certain condition already that has already happened. Okay, so I've got an example that says, what is the probability that the total of 2 dice will be greater than 8, given that The first die is 6. So you're already told that the first die is already 6. So what you need now, you need to find out what will be the number of the second. What will be the number of the second die that will actually add up to 8? Which means for you, if you have got a 6, for you to get an 8, either you might get the second die, you might get what there are chances of, what is the probability that the total of 2 dice will be greater than what? Okay, the question is saying will be greater than 8. So you know that the only values that will give you greater than 8 is for the second die maybe to be what? To be 3. If you get 3, because if the second die is going to be 2, you're going to say 2 plus 6. 2 plus 6 is going to be 8, which means it's not greater than 8. So the second die have to be maybe 3. If you say 3 plus 8 gives you 9, which is greater than what? Greater than 8. Okay, or it's going to be 4. 4 also is going to be 10, greater than 8. Okay, or it's going to be 5, the second die, which is also greater than, or it's going to be 6. So these are only options that might happen. These are favorable outcomes that might happen. So when you're actually finding those outcomes, you have to actually count how many possible outcomes that give you what? Favorable outcome that give you greater than 8, which is 1, 2, 3, 4. So which means it's going to be 4 divided by the total possible outcome. The total possible outcome, which means you might get the second die might be 1, might be, so you get 6, 1, or it might be 2, which means 6 what? 6, 2, or it might be 3, which is the one that is on screen now, which is the third one, or it might be 4, which is the fourth, or it might be 5, which is the fifth, or it might be 6, which is the sixth. So which means the total possible outcome are 6 outcomes that might happen. So you are saying 4 favorable outcome divided by total possible outcome, which is 6. So 4 divided by 6 is going to give you 2 thirds, which is 2 over 3. That's when you reduce 4 over 6. 4 divided by 6 is going to you are going to reduce it to 2 over 3. So the answer, that's how we get what 2 over 3 is your answer. So this question is pretty simple. So you are given the condition now. The first die is already 6. So what would be the value of the second die that will make it to be greater than what? The total to be greater than what? To be greater than 8. So that's will be actually focusing on the second die, so that you combine with the first condition that we already given in order to calculate that probability. Okay, I hope it's clear. So I think that's all what I have for now on probability. So on the simple probability. So the next thing that we have is the discrete probability, which you have got permutations, combinations, binomial distribution, and Poisson. Okay. So on the permutations, you have to know also what is permutations. I think I left with some minutes, but let's try to push a little bit. Then I will left 1 minute or only to find out if there are any questions. Okay. So we have what we call permutations. So in this normal distribution, we have what we call permutations, we have what we call combinations, we have also what we call the binomial distribution, and we have what we call the Poisson distribution. So in probability, all these actually are mathematical theorems that are applied in statistical study in the field of a probability distribution. So you should actually know how to apply them and which situation where you can apply those calculations, and how you do calculations whenever you encounter the question that you need that application of permutation. So a permutation is a mathematical calculation of a number of ways a number of ways a particular set can be arranged, where the order of the arrangement matter. So when you are saying how many ways can you arrange the items that you have, maybe you've got 5 books or 10 books in your office, and say how many ways, but in those 10 books that you have, you only have a shelf that will fit 4 books. So I say, how many different ways can you arrange those 10 books in the shelf that actually fit only 4 books? So when you actually find the different ways that you can put, which means you can actually put 4 different books, or you can replace that one with another one, different books. There are so many ways that you can arrange. So when you're calculating the number of ways in which you can actually arrange something, or the number of ways in which you can share or divide some objects in a certain group, you can actually use this concept of permutations or combinations. So in permutations, the number of ordering of your items in permutation, it matters. But in combination, the number of ordering doesn't matter. So that's the difference between permutation and combination. But the applications is applied in the same field, where you actually want to find maybe the number of arrangements, or how many ways you can group, or how many ways you can divide some objects in a certain group of people. Or if I say in a class of 30 students. Say, how many ways can you group those 30 students in a group of 5? So you can be able to find the different ways in which you can group 30 students in a group of what? In a group of 5. But those ways, if I ask you now how many ways, you can actually use the statistical concept of permutations or combination in order to come up with what? With the number of ways in which you can group those people or certain objects in certain groups. Okay? So permutations, the order matters. So any ordering, if you put two objects and say A, B, C, and B, C, D, that ordering is different of the same. They are same letters, but the order is different. So once it's different in ordering, we call it as a different what? As a different grouping in what? In permutation. But it's different from combinations. Combination is actually considered as what? As the same thing. As combination, it consists of what? It checks whether those components are still the same components that are in the group. So if they are the same components, they consider it as the same what? As the same grouping, which is only one group. It won't be treated as the different what? Different grouping. So an example that I have, like your pin, your bank pin, that is actually the one that you use, the card pin. The card pin of your card, actually for bank pin, it has got 4 digits. So if I can say, how many ways can you actually guess? How many ways can maybe even a thief can try to guess your 4-digit pin from the numbers? You know that your 4-digit pin is actually come out from numbers 0 up to what? Up to 9. So if I say, how many ways can a thief try to guess your 4-digit pin from these numbers of what? Of 0 up to 9. So you can actually calculate those number of ways, or how many of them. That's why it's actually sometimes it's difficult, because it actually gives 1,000. So there's a formula for permutations when you want to calculate the number of ways in which someone can actually try to arrange those numbers in a certain group of what? Of 4 different types of what? Of numbers in a certain grouping. So permutations, for example, that I was giving here. Example, how many ways can you arrange the letters A, B, C? So A, B, C, how many ways can you arrange? Which means when you arrange the letters A, B, C, you can arrange this as A, B, C, like A on the first place, B followed by B followed by C. You can arrange in that way. Or you can arrange A, then you put C in between, or put B. But if you check here, this thing actually is the same object, is the same components that are actually putting in different arranging. So in permutations, you consider as long as you change and put this one on the second, here on the first one, A is on the first one, on the first position, but here A and C is no longer on the last position, is on the middle. It's treated as what? As different to what? To this one. So we consider in permutations as different object, as long as you change the structure or the ordering of what? Of your object. Then it will be treated as what? As different arrangement. That's permutations. But when you come to combinations, this ABC, as long as it's composed of the same object, which is ABC, even if you change the arrangement and say it's now called BCA, it will be actually treated as one grouping in combinations. So you should know the difference between permutations and combinations. Okay, we're going to actually check the example for combinations now. So in permutations, all these will be treated as different what? Different grouping, even though it's made up of the same object. But because the arrangements are different, so we treated them as different what? Different arrangements. So if you check, we have got 4 ways we can arrange A, B, C into what? We've got 6 ways we can arrange them. If you check these ones, they are different in what? In arrangements. There's no even a group that is similar to the other here if you check them, okay? Okay, guys. Are we still together, guys? Guys, are you still together? Do you have another lecture now?
Yes.
Okay. All right. Because I don't want to take much of your time, because I think time is already gone. But what I can do is, everyone on the WhatsApp group, guys?
I believe so.
Okay, I'm going to send this slide in the WhatsApp group. So if you check here, I have all the formula for permutations. I have also examples. Then I have also combinations. Then examples of combination, the formula for combinations. Then I have also even the last chapter, which is the binomial. I have almost everything on this slide. So I'm going to send this slide. So Another part that we haven't go through now, we're gonna go through that part, I think, in our next in our next workshop. So I'm going to send this slide so that you go through this slide until to the end in preparation for our next, so that when we meet in our next workshop, you'll be actually familiar with all other things that we are going to go through. Are we together on that? Are we together, guys?
Yes, sir.
All right. Any questions? Any questions? So don't forget, guys, you can also check on my, you can just communicate with my, on my email. If you've got any problem, just send me a message as well. Then if you don't, if you're not in the group, I might actually then respond to you through WhatsApp or email. This is my email and my contact. You just send me a message there, then I'll forward the slide to you.